Hi everybody, Michael Brown here with you. Welcome back to Educator.com's Adobe Photoshop Elements Beginning and Intermediate course. In this lesson, we're going to have a discussion about light and color and how they apply to what we're doing in Photoshop Elements. In the last lesson, we talked about quality and how to set your camera up to take the best technical image we possibly can. What is your sensor actually taking an image of or sensing? Photons of light, not the scene, not the composition. It captures light. So the quality level of that light, the intensity of that light is very important in the chain of best quality from start to finish. So let's get started. What is light? Technically, it is electromagnetic radiation that our eyes can interpret, the little rods and cones in your eyes. It's called vision. The electromagnetic radiation are photons of light from the light source. And in our lives, outdoors mostly, that's the sun. Indoors, it's various light sources. We perceive light as a range of two things, brightness and color. That's why I said in the last lesson, the four categories of Photoshop: corrections, exposure, and color. Exposure is brightness, color is the other one. Brightness is the intensity level of the light, more or less, brighter or darker. In the daytime at noon, it's brighter than it is at sunset. The color is the temperature of the light. Higher temperatures are more bluish, lower temperatures are more reddish. In the afternoon, you can see this as the sun goes towards sunset. It slants through the atmosphere more. There's more particles in the atmosphere. The photons bounce around, and you begin to get a more reddish tone. You're also getting less light because it's getting closer to the horizon, and so the color changes of the light. Noontime, it's very crisp. Late afternoon, it's very warm. A match or a candle is kind of an orange-yellow, lower color temperature. It can't melt metal, but it can sure boil water. A welder's torch, very hot, very blue, melts metal. There's the difference in color temperatures there. A mantra for exposure and color. Exposure affects color. Color does not affect exposure. You want to make exposure changes first, get your exposure right, then adjust your color. If you do it the other way around, the exposure will alter the color. Let me give you an example of that. This is an image I took in Colorado, a nice fall scene in the mountains. And I'm going to show you how the color is affected by exposure. Notice cyan sky over here, blue sky, nice blue lake, yellow aspen with a tinge of orange, kind of warm color, and the grass is kind of orangey. As I increase the exposure or make it brighter, watch the colors. Notice the colors of the grass are becoming less red. The aspen are becoming also less orangey, more yellow. The sky is pure cyan over here, and the lake is adding cyan and becoming a lighter color. Go back and you'll see the color difference. The exposure is affecting the color. We'll drop down and the other way. Darker it gets, notice that the aspen are becoming very orange now. The grass is almost red. The lake has a purple tone to it. The sky's blue here and almost blue-purple over on that side. A function of the exposure changes. Now, how does color affect it? As we increase the saturation of color, the colors become much more rich, but you notice the exposure, even though it's way up there, the exposure doesn't change, just the color. We desaturate. Exposure doesn't change. So you want to do your exposure corrections first, and your color corrections second. All right, moving on. We see light in one of two ways. Transmitted light. This is light that is actually being projected at us. That is monitors, television sets, computer screens, smartphones. Beams of light are broadcast directly at your eyes. A flame is broadcasting right at you. The lights that are lighting me here in the studio are broadcasting at me, but you are seeing reflected light. In your monitor right now, you're seeing projected light because your monitor is projecting it, but the original light on me is being reflected into the lens. Reflected light is absorbed by ink and paper, and the color you see is the remaining reflected wavelengths. If you're looking at a stop sign, you're not seeing the actual color, you're seeing the reflected light because the sun's light hits the stop sign and absorbs all of the colors with exception of the red that are transmitted back to you. The same with printed paper. You're seeing the light from your light or the sun or whatever you're viewing the print under, absorbing everything but the colors that come back. A totally different type of light. The transmitted light from your computer is additive. It's made up of red, green, and blue components. They combine to make the entire spectrum. White is all of the wavelengths. Black is no light at all. Turn off your computer. The screen goes black. Reflected light is subtractive. And that's what I was just talking about. In printing, the inks are cyan, magenta, yellow, and black. These combine to create all colors. Black is all of the colors on paper. White is no color. Here's paper with no printing on it. It's white. Once the ink gets on it, it will reflect the colors. Why is this important in Photoshop Elements? Your photos or graphic art are output to two primary sources. The web, which works with the red, green, and blue projectors coming out at you, or in various print sources, which work with cyan, magenta, yellow color ink. It is vital to have your files in the correct color range or color space to ensure you get the best color output. And a quick demonstration. Look, RGB has pure reds and greens and blues. Over in cyan, magenta, yellow, black, there are no pure reds, greens, blues. So the color is going to be a little different for each of those sources, and you have to make sure it's right working with your monitor. So what a range of color is called a color space, a gamut. And there are 5 primary ones. The visible color range that we see with our eyes, and in this chart, that's the one that peeks out in the back. That's the wider one. That is all that we can see, all of the color that our eyes see. ProPhoto is the largest working color space that we can do in a computer. It's used primarily for high-end pro work. It's used in 16-bit color mode, a gazillion colors, colors that you can't even see. As you see the triangle, the big triangle, sticks out. It has blues that you can't even see with your eye and greens. Why is this good? If you work in a larger color space and you compress it to a visible color space or a usable color space, just like higher resolution giving you more detail, the more colors have more detail in them, and when you compress it, the final colors will be a little bit better. But we can't work in ProPhoto. I just wanted to show you that. The two that we work in, Adobe Rgb is available on all cameras and, of course, in Photoshop and Photoshop Elements. This is our recommended color space to use most of the time. Srgb is the default color space for JPEG images in your camera, and most cameras, monitors, and for Photoshop and Photoshop Elements. Your cameras come default in Srgb, but you can set them at Adobe Rgb. And let me define why. This is the Adobe Rgb color space, this middle triangle right here. Falls within the visible spectrum, has less than the ProPhoto, but it's got a good range of colors. Srgb, the default for JPEG, the default for the cameras, and the default for your monitors is the smaller triangle. Notice, greens, light blues, a lot less. Also, a little bit in the yellows. So it's a smaller color space, primarily greens and light blues. So if you're shooting with a camera, obviously you'd want to set it at Adobe Rgb to get more color. The other reason is that the final color space is CMYK, which is the color space for printing with ink on paper. And you notice that's the oval. Compared to either Adobe Rgb or Srgb, it has much less blues and greens. A little more greens than the sRgb, but really falls in the blues, and on both of these, Adobe and sRgb, in the reds. So if you're going to print, you don't want to be setting it up in sRgb because there are less greens, and obviously, yes, less yellow anyway, because cyan, magenta, yellow, black can reproduce yellow. But you lose a lot if you try to take sRgb and set it up for print. Adobe Rgb is the best space for setting up for print. To make this simple, for consistency and to give yourself plenty of color range, set your cameras to shoot Adobe Rgb. Another reason to shoot RAW in your camera, because JPEG, you can't get Adobe Rgb from it, only sRgb. So you want that wider range, better quality. In Elements, you have only two choices for color space, sRgb and RGB. I will show you. Convert to Profile. You have sRgb or RGB, the only two choices. When optimizing for computer screens, which are sRgb, use sRgb. You're seeing just what you get. When optimizing for print, use RGB because that's a little bit wider color space than the CMYK, but you also have to be careful because there's going to be a fall off in the blues and greens when you go to print. Now, setting your color spaces. When you first open a file, you can choose which one to assign right from the beginning with the file so that you will have the proper color space for your final output. Go to Edit, Color Settings, right here, and up comes this box. No color management, leaves the incoming file just the way it is. If you're working, for example, for computer screens, you want sRgb. But if you shoot your image in the camera in Adobe Rgb, you can bring it in as sRgb. Once you bring it in, it's still the original file as RGB, so you can go back to it if you want, if you're going to be working for print. But if you're working for the monitor, you can switch it automatically to sRgb. If you're working for printing, use Adobe Rgb. It's the larger color space. And then you have the option of choosing them. In other words, if you check this box when you open a RAW file or the first time, it will ask you which one you want. When in doubt, use RGB, the larger color space. To change a file from sRgb to RGB, go to Image, Convert Profile, and you can do it right there. So there you have it. A little talk about light and the value of light and how we need to make sure that the light is of the highest quality and correct light for either working on monitors or printed outputs. In the next lesson, we will talk about how to calibrate your monitors for proper output and for other web devices. That wraps up this lesson. I'll see you in the next lesson.